Ever wondered why a hot cup of coffee cools down when left on the table? The answer lies in the Zeroth law of thermodynamics. This law, while it may sound complex, is a fundamental principle that governs the very core of our perception of heat and cold. It's defined as, if two systems are each in thermal equilibrium with a third, they are in thermal equilibrium with each other. But what does this mean? Well, in layman's terms, if you have two objects, let's say a hot cup of coffee and a cool table, and they are both in contact with a third object, in this case the surrounding air, they will eventually reach the same temperature. This principle is what establishes the concept of temperature, a measure that we use every day. This law is the foundation of thermometer readings and why we perceive things as hot or cold. The Zeroth law of thermodynamics is not just a scientific concept, it plays out in our everyday lives. Let's delve into a couple of examples that illustrate this principle in action. Picture this: you've just brewed a steaming hot cup of coffee and left it on your kitchen counter. You get caught up in some work, and when you come back to it after a while, you find that your once hot coffee has cooled down. What just happened here? The Zeroth law of thermodynamics happened. The hot coffee and the cooler room are two systems that initially are not in thermal equilibrium. The coffee, being hotter, loses its heat to the room, which is cooler. It continues to do so until both the room and the coffee reach a common temperature, a point at which they are said to be in thermal equilibrium. This is the Zeroth law at play in its simplest form. Now let's consider another scenario. Imagine you've just poured yourself a glass of room temperature water and you decide to drop a few ice cubes into it. What happens next? The ice, being at a lower temperature than the water, starts to absorb heat from the water and melts, while the water gets slightly colder. Again, this is the Zeroth law in action. The ice and the water are trying to reach thermal equilibrium. The heat flows from the warmer water to the colder ice until they both reach the same temperature, achieving thermal equilibrium. These examples are far from exhaustive, but they do a good job of illustrating how the Zeroth law of thermodynamics manifests in our daily lives. It's the underlying principle that governs the flow of heat, the melting of ice, the cooling of your coffee, and countless other phenomena. In essence, the Zeroth law of thermodynamics is the reason behind the flow of heat from a hotter body to a colder one until equilibrium is achieved. Let's delve into more everyday examples of the Zeroth law of thermodynamics. Our third example is something we've all experienced. Imagine you're sitting in a room and you reach out to touch an object that's been sitting there for a while. It feels cold, doesn't it? But why is that? You might say it's because the object is cold, but the real reason is a bit more complex, and it's all about the Zeroth law. You see, your body is generally warmer than the room temperature. When you touch the object, heat flows from your body, which is at a higher temperature, to the object, which is at a lower temperature. This transfer continues until both your hand and the object reach thermal equilibrium, that is, they become the same temperature. And it's this loss of heat from your body that makes you perceive the object as cold. Moving on to our fourth example. Imagine you've just taken a pan out of the oven. Naturally, you wouldn't touch it with your bare hands. But why? Well, it's because the pan is hotter than your body temperature. If you were to touch it, heat would flow from the pan to your hand until both reached thermal equilibrium. This sudden influx of heat into your body would cause a sensation of burning. And here's the interesting part. In both these examples, the object doesn't have to be in direct contact with your body. The Zeroth law also applies if there's a medium like air or water between your body and the object. Heat would still flow from the hotter body to the colder body through the medium until all achieve thermal equilibrium. So whether it's a cold soda can on a hot day or a warm blanket on a chilly night, the Zeroth law is always in action, subtly but constantly governing the flow of heat in our world. As we can see, the Zeroth law of thermodynamics is constantly at play, governing the flow of heat in our everyday lives. The Zeroth law of thermodynamics has significant practical implications. Imagine a world without thermometers. It sounds simple, but it's quite complicated. This essential tool, which is a household item in many parts of the world, relies on the Zeroth law of thermodynamics. The law allows us to measure temperature, a fundamental property of matter, by establishing a concept of equilibrium. Here's how it works. When a thermometer is placed in contact with a system, say a human body when you're checking for a fever, the thermometer and the body reach thermal equilibrium. According to the Zeroth law, if the thermometer is in equilibrium with the body, and the thermometer is also in equilibrium with a standard reference, like an ice bath, then the body and the ice bath are in equilibrium. This is the principle that allows the thermometer to measure your body temperature. Now, consider the importance of temperature in various fields. In science, accurate temperature measurements are crucial for experiments. Researchers need to know the exact conditions of their experiments to replicate them and validate their results. Without the Zeroth law, this would be impossible. In engineering, temperature is vital for designing and testing materials. Engineers need to know how materials will behave under different temperatures to ensure safety and efficiency. Again, none of this would be possible without the Zeroth law. In medicine, doctors use temperature to diagnose and monitor illnesses. A slight change in body temperature can indicate a serious condition. And what about cooking? Recipes often require precise temperatures to achieve the perfect dish. From baking a cake to roasting a turkey, temperature is key. In a nutshell, the Zeroth law of thermodynamics provides the basis for the concept of temperature, allowing us to make comparisons and measure changes. It's a fundamental principle that's deeply embedded in our lives, even if we're not always aware of it. So there you have it. The Zeroth law of thermodynamics, a fundamental law that governs heat flow, defines temperature, and impacts our daily lives in more ways than one.